Hello, Bismillah, Alhamdulillah, wa salatu wa salamu ala Rasulullah sallallahu alayhi wasallam. Okay, let's get to work. So we have title: How Islamic scholars shape the first equation of motion. Duration about 13-14 minutes. Okay, Bismillah. Introduction. Hey everyone, welcome to today's video. Today I'll be sharing something you might not have thought about when you learn Newton's first equation of motion. Okay, it's a simple equation. V equals U plus AT. But here's the twist. This equation, like so many other things in the history of science, didn't appear out of thin air. No, it didn't. The real story goes much deeper. And to understand it fully, where's it gone? But here's the twist. This equation, like so many other things in the history of science, didn't appear out of thin air. The real story goes much deeper. And to understand it fully, we need to look at the massive contributions from Islamic civilization and the Islamic Golden Age. In this video, we'll break down the equation itself and explore the often overlooked Islamic roots of its classical mechanics, while also connecting this discussion to things like Edward Said and Professor Jonathan Lyons, who've written about how the West has overlooked these contributions. So let's get into it. First equation of motion. First things first, what does the equation V equals U plus AT actually mean? V is the final velocity of an object. U is the initial velocity or how fast it was moving at the start. A is the acceleration or how much the object speeds up. T is time, the duration over which this acceleration takes place. Now, you probably learned this in school, or maybe you're just hearing it now for the first time, but there's a hidden story behind it. This equation is fundamental in Newtonian mechanics, and Newton often gets the credit for it. But if we dig deeper, we can trace the intellectual lineage back to the Islamic Golden Age, a time when scholars from the Islamic world were making groundbreaking contributions in math, astronomy, and yes, physics. Islamic Golden Age, the real roots of classical mechanics. Let's travel back in time to around 8th to 14th centuries. The 8th to 14th centuries, when scholars like Ibn Sina, known in the West as Avicenna, and Ibn al-Haytham, also known as al-Hayzen, were pioneering new ways of thinking about the natural world. During this period, Islamic scholars were not only preserving the knowledge of the ancient Greeks, but were also expanding upon it. Ibn Sina, for example, made significant contributions to our understanding of momentum and inertia. He proposed that objects in motion will stay in motion unless acted upon by an external force. Sound familiar? This is pretty much the foundation of Newton's first law of motion. So let's read that again. Ibn Sina, for example, made significant contributions to our understanding of momentum and inertia. He proposed that objects in motion will stay in motion unless acted upon by an external force. Sound familiar? This is pretty much how the foundation of Newton's first law of motion. Think of these scholars as the intellectual predecessors to Newton. They were not just cataloging ancient texts, they were actively engaging with and improving upon the knowledge they inherited. What you don't learn in school, the impact of Orientalism. Now, you might be asking, why don't we learn about the Islamic scholars when we are taught physics? That's a great question. And to answer it, we need to understand the concept of Orientalism, a term coined by Edward Said. Said's work, Orientalism, examines how the West has historically misrepresented and marginalized the contributions of the East. Said argues that the West constructed a view of the East, especially the Islamic world, that framed it as backward, passive, and exotic, while the West positions itself as the modern rational center of progress. This selective memory not only erased Islamic contributions from the narrative of science, but also perpetuated a false story that science and modernity were the exclusive domains of Europe. This is where Said's critique becomes crucial for understanding why we don't often hear about figures like Ibn Sina or Ibn al-Haytham in school. The West tended to attribute all scientific progress to European figures, neglecting the rich contribution of the Islamic Golden Age. As a result, when we think of mechanics, we jump straight to Newton without acknowledging the foundation that scholars from the Islamic world laid. Jonathan Lyons, and Islam through Western eyes. Let's take this even further by looking at the work of Professor Jonathan Lyons, who dives into this issue in his book, Islam to Western eyes. Lyons argues that the West has systematically overlooked the intellectual achievements of the Islamic world. He shows us how Western scholars often treat Islamic civilization as merely the caretakers of Greek knowledge, without recognizing the true innovations that were made. For example, Al-Kindi, another important figure from Islamic Golden Age, is known as the philosopher of the Arabs. He worked extensively in optics, a field that would later influence physics. He was not just copying Greek texts. He was expanding on them, laying the groundwork for what would eventually become concepts like acceleration, a key part of the equation of motion, V equals U plus AT. So when we talk about the first equation of motion, we're not just talking about Newton, we're also talking about centuries of intellectual development that took place in the Islamic world. Islamic contributions to classical mechanics. Now, let's focus on the specific contributions Islamic scholars made to the fields that directly led to the creation of classical mechanics. Ibn al-Haytham, often called the father of optics, was not just a physicist. He pioneered the scientific method itself. His emphasis on observation, experimentation, and verification laid the groundwork for modern science. His work on light and motion influenced the development of mechanics in Europe. Then we have Al-Biruni, another giant from the Islamic Golden Age. He conducted experiments on everything from speed of light to the density of the Earth's materials. He also explored the principles of motion and gravity long before Newton was even born. These scholars were making breakthroughs that would eventually become the foundation of what we now call classical mechanics. In many ways, the story of V equals U plus AT is a testament to the collaborative nature of science. The equation represents centuries of work from scholars across different cultures, and we should acknowledge the key role that Islamic civilization played in that journey. A hidden legacy and a missed opportunity. So why does this matter? Why should we care that Islamic scholars were making contributions to science 1,000 years ago? Because history is often told through a very narrow lens. The way we understand the history of science shapes how we think about modern science too. When we overlook the contributions of the Islamic world, we are missing out on a full appreciation of the global nature of human knowledge. And this brings us back to the idea of Orientalism and the arguments made by Edward Said and Jonathan Lyons. The West has long minimized or ignored the contribution of Islamic civilization in order to build a narrative of scientific progress that centers Europe and the West. But science is a global effort, and by recognizing the work of scholars like Ibn Sina, Al-Biruni, and Ibn al-Haytham, we're not only being more accurate, we're also honoring the full legacy of human knowledge. Pulling it all together. All right, let's bring this all together. The equation V equals U plus AT is something we've all seen in physics textbooks. But it's so much more than just a formula. It represents the work of countless scholars across different civilizations, particularly those from the Islamic Golden Age, who played a crucial role in the development of classical mechanics. By understanding the real history behind this equation, you can see how interconnected science truly is. Newton didn't invent these ideas in isolation. He built on the work of scholars who came before him, many of whom were from the Islamic world. So next time you see this equation or any of Newton's laws, remember that behind these formulas are centuries of intellectual exchange, collaboration, and innovation that cross continents and cultures. Conclusion. I hope this video has given you a new perspective on the history of science and the real story behind the first equation of motion. If you found this interesting, hit that like button and subscribe for more deep dives into the forgotten stories of science and history. Let me know in the comments if there's another topic you'd like to see covered. Maybe there's more to the science you thought you knew. Thanks for watching, and until next time, keep learning. Assalamu alaikum.